Next problem. Which condition allows you to prove that line L is parallel to line M? This is just a friendly reminder about knowing about parallel lines cut by a transversal. There are alternating interior angles, alternating exterior angles, and corresponding angles are all congruency, which means if you can find an alternating interior angle, a pair of alternating exterior angles, or a pair of corresponding angles, they are congruent. And since we have 4 options here, and they're all talking about congruency, those are the 3 we're going to talk about. However, if you know that same side interior angles are supplementary and same side exterior angles are supplementary, or supplementary angles are add to equal 180 degrees, that is also useful. But we're talking about congruency right now, so let's stick with our 3. We have angle 7 congruent to angle 6. Well, we just got finished talking about supplementary angles. The sum of supplementary angles are 180 degrees, but they're not congruent. Then we have angle 7 being congruent to angle 1. Well, those are same side exterior angles, and they add to equal 180 degrees, but they are not congruent. Now we have angle 8 being congruent with angle 2. Well, these 2 angles aren't even related, so we wouldn't even be able to prove without some numbers that they are congruent. Finally, I guess by process of elimination, angle 7 being congruent to angle 2. Of course, these are alternating exterior angles, and they are congruent. We're going to prove which statement proves that angle ACB is congruent to EGF. Now, this statement isn't speaking to what we already were given. We were given that AB is congruent to EF. We are also given that angle B is congruent to angle F. We are also given that BC is congruent to FG. So we can prove that these 2 triangles are congruent by side angle side. But just because they're side angle side, that postulate or theorem does not tell us about an angle that's not identified. And there's no such thing as side angle triangle congruency. And because this isn't a right triangle, we can't use hypotenuse leg. But corresponding parts of congruent triangles are congruent. And since it's already told us that these triangles are congruent through side angle side, we know that all the other corresponding parts are also congruent. We are given that angle BAP is congruent to KEP. That's given. I marked it. We're now going to prove that triangle ABP is congruent to triangle EKP. Now, what information is needed to prove this congruency? Well, we already marked the given. Is there anything else we can prove by just looking at this triangle? Well, we know that vertical angles are congruent. And this angle KPE, angle KPE is congruent to angle BPA. Angle BPA. How? Because vertical angles are congruent. What else do we know? Nothing else. But if we're going to prove these triangles are congruent, there are 5 congruency theorems that we use to prove triangle congruency. Hypotenuse leg, side angle side, angle side, angle, side, angle, sorry, and side, side, side. Well, we can cross off hypotenuse leg because we don't know if these triangles are right triangles anyway. And we can cross off side, side, side because we know two angles. We don't know any sides. Well, we have two angles and not just one, so side, side, side cannot be one either. So we're left with these two. So we either need to know that AB is congruent to EK, or in order to prove angle, angle, side, or we need to know that BP is congruent to KP in order to prove angle, angle, side. Angle, angle, side, or angle, angle, side. This side or this side. So we need to know that, or we need to know that AP is congruent to EP in order to prove angle, side, angle. So we need a side, some information on a side. These triangles are, what do we know? Well, I know that this 8 is proportional to this 4. If I take 2 and multiply by 4, I get 8. If I take 3 and multiply by 2, I get 6. If I take 2 and multiply by 2, I get 4. That means these triangles are not congruent because 8 and 4 are not equal, and 6 and 3 are not equal, and 2 and 4 are not equal. They are proportional. So we know they're not congruent, they're proportional, which means they're probably similar. How do we know this? There is a postulate that says angle-angle similarity theorem. You are welcome to look it up. But because we know our algebra, we can make the assumption that they are similar and not proportional. And not congruent. Let's write a similarity statement for this figure. Let's start with the first triangle. There is a large triangle called ABD. And if I name this triangle, in whatever direction I name it, I have to name all the other triangles. I'm choosing to start with the right triangle because it is easily identified. So I'm going to name this triangle ABD. Next, I'm going to try to name this medium size triangle. This medium triangle's right angle starts here. So going in the same direction, which is across the short side, be careful because it's flipped, across the short side and then across the hypotenuse, I'm going to say CAD. Now, it doesn't look like I went in the same direction, but I did. This is the short side of this big blue triangle. And then here is the hypotenuse. How do I know? It's directly across from the right angle. So for the green triangle, I went across the short side, which is right here, and then across the hypotenuse, which is directly across from the right angle. Now for the pink triangle. I'm going to go directly across, here's a 90-degree angle, across the short side, and then across the hypotenuse. I have found my triangle. These are similar, which means that they have proportions. The sides are proportional, but the angles are congruent. Which information or what information is needed to prove angle-angle triangle congruence? Well, what do I know? I only know that segment AC is congruent to segment AC. That is reflexive property. So if I'm trying to prove angle-angle side, I need to know about two angles. So what can help me find two angles? Well, if this line here is an angle bisector, I could prove my two angles. Want to see? That would make angle BAC congruent to angle DAB, because by the definition of angle bisector. But that would also prove angle D is congruent to angle B, because the angle bisector theorem says if I have any point on the bisector connected to one of the legs of the angles, they form a right angle. And that means 2 right and 90 degrees equals 90 degrees. So that means angle CDA is congruent to angle CBA. Wow, that angle bisector theorem packs a punch. I do appreciate your time and thank you for having a wonderful second quarter. See you soon.